Hello everyone, and welcome to this Ask AuxEn Anything online session. And as you all know, this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any steel design or RCC design concept or any project that they are doing or construction and site issues. So, this is the 39th such session that we are conducting, and let us begin with the queries that we have for this session. So as we always do, we will first take up the queries from the Google form and email, and then we will take up the queries in the live comments. So let me share the screen. Yeah. So the first question is from engineer Rohit. He is from Himachal Pradesh and he is a working professional. So what he is asking, he has this doubt regarding the clause that is given in IS 1893 about that time period lateral irregularity, where the time period need to be 10% away from each other. So regarding this clause, he has certain queries. Just a minute. So let me what I will do is, basically this provision is from this table number 5, no sorry, table number 6, but then there is an amendment to this clause. So I'll show that amendment to you. Before that, I'll show that original clause. So this is that original provision. Okay. This is that original provision, but then there is an amendment to it. So let me show you the amendment. Just hold on. So where is that amendment? Yeah. So on your right side, what you see is the amendment. This is the first part of the amendment, amended provision, and then this is the second part of the amended provision. Yeah. Let us try to understand. So irregular mode of oscillation in two principal planned directions. So stiffness of beams, this. A building is said to be laterally irregular in principal planned direction if these two provisions are met, or if these two conditions are met. Both of them have to be met because it's an and. So a building is said to have lateral irregularity. What are those two conditions? The first three lateral translation modes contribute less than 65% mass participation. This means in x direction, let's say you have to take the first three modes. The numbering of modes may be 1, 3, 5, or they may not be in serial order, but the first three modes from your mode participation list, where you can see mass participation in x, that you have to pick up. Similarly, the first three modes in the y direction, where you see participation in y happening, that you have to pick up, and then sum up their mass participations. They should be less than, sorry, they should be more than 65%. That is the first provision. The second, not provision, first condition. The second condition is the fundamental lateral translation natural periods of the building in the two principal planned direction are closer to each other by 10% of the larger value. So what this means, let's say time period in X is 1.54 seconds. Okay, and this was your first mode. So this became my principal fundamental mode in X direction. Similarly, for Y direction, my time period was, let us put it this way, it was 1.45 seconds. Okay, this was your second mode as per this list. Now, what is happening? They are saying that these are closer to each other by 10% of the larger value. So, what is the 10% of this? So, 10% of this is 0.154 seconds. So, you subtract 1.54 minus 0.154. How much is it? Just do it. So, it comes out to be 1.386 seconds. Now, what's happening? That your time period for Y direction, you are getting 1.45. So, this means in this case, the two time periods are closer to each other by 10% of the larger value. So, both of these conditions are being met, and therefore you will say that this building has lateral irregularity. Is that understood? Why this is given, this 10% thing, why is it given? Because you do not want to have interference effects when your time periods are too close to each other for two fundamental directions. uh, there may be an interference effect that you want to avoid, and that is what is being written over here, or that is what is required by ensuring that the time periods are further away from each other by 10% of the larger value. Understood? So this is this provision, and then it goes on further saying that if lateral irregularity exists in any of the principal plan direction, and then if your seismic zone is 2 or 3, then it shall be ensured that the first three, this. For seismic zone 4 and 5, it shall be ensured that both these things shall be ensured. So then you may have to make changes in your structural configuration to ensure these things depending on your zone. Understood? Okay. So this was this question, and this was this provision. Now we move on to next query that has been asked by engineer Manish. So engineer Manish is from Dehradun. He is a working professional. So he is asking how to so he is asking related to punching shear calculations in case of shear walls. Okay. How many of you have faced this issue that in safe, let's say you are doing and you have modeled a shear wall, and then because safe or ETABS does not give punching shear values for shear walls, you face difficulties? How many of you have come across this problem? Hello? No one? Because these softwares typically give punching shear calculations for columns. They don't give it for shear walls. So his query is related to this shear wall calculation, and he has shared one image also. So typically the punching shear stress is calculated like this. Typically the punching shear stress is calculated like this. This is the formula. And in our course on flat slabs, we have done manual calculations also, verified the results with the safe outputs. So this is your shear, total shear, downward shear on the area, which is at the d by 2 distance. This is vu upon a. Then these are the unbalanced moments. Okay, these are my unbalanced moments. Now generally these softwares, they calculate the unbalanced moments on their own, So for columns, when you define your members as columns, the software is able to do these things on their own. The question being asked over here is that if you want to do it for shear wall, how to calculate that unbalanced moment? So anyone in the live audience who has faced this problem, where they had modeled it a shear wall, and then the software was not giving them the results. So what are you guys doing over there? Hello. See, one thing is people take directly the shear stresses. Okay. In some cases, people or engineers just directly look at the shear stress being given by the software and compare it with the tau c value for punching, or then you can prepare some kind of an Excel sheet, and in that you can put this formula. But for that you will need these unbalanced moments. So how to calculate these unbalanced moments? So one of the ways could be to manually, let's say this is my slab in plan view, and I had these shear walls. Okay. And let's say this is the critical perimeter d by 2 distance. Now if you want to have the unbalanced moments, one of the ways can be that you make a strip. So this is the strip in this direction, and then you make another design strip. So this design strip is in this direction. Let's name it as design strip 2, and let us name this width as design strip 1. Now how to figure out what should be the width of these strips? So the width of these strips will depend on the width of the strips width of the strips depend on your span. Okay. Span in both directions, and the general behavior on that, the width of the strip will depend. So what you can do is, in software you can just model these strips having this width, which will depend on the spans in both directions and the sizes of your elements. For this you could take help from some codal references where they tell you what shall be taken as an effective strip width. So you take that strip width, and what do you do? So when you let's say you were to check the analysis results, suppose you were getting this type of a moment diagram. I'm just drawing some hypothetical moment diagram over here. Okay. Now what you do is, unbalanced moments will be, so whatever moment value you get over here. Now I am not sure if that unbalanced moment needs to be taken at the face or it needs to be taken at the d by 2 distance. I'm not sure about whether that unbalanced movement needs to be taken at the face of this wall, or should it be taken at the critical perimeter, which is at d by 2 distance. I need to think about it, but or I'll just refer to the software calculations also. But from for unbalanced movements, you could do the calculations from here. So let's say this is the mu1, and this is the mu, or this is mu left, this is mu right. So your mu right minus mu left will give you the unbalanced movement in this direction. Similarly, for the other direction, again you will see the strip results. You could see the strip results. Again, this confusion, I'll try to think about it, that this unbalanced movement value, do you need to take it at the face or you need to take it at the critical distance? But uh, let's say we keep that point aside right now. Unbalanced movement will be calculated like this. So from in the other direction also, you will get some mu right and mu left, and unbalanced movement will be, let's say, mu right minus mu left. So this can be one of the ways to calculate the unbalanced movements. You make a strip. That strip width should be representative of the behavior, and for that it will depend on the span, and you might take help from some codal provisions which will tell you what should be an ideal strip width for your condition, and then the difference of the moments from the strip results, that you can take it as uh, the unbalanced moment. Okay. Shear, for shear you can use the approximately, you can, if you don't have any outputs, either you can take the axial load getting transferred to the wall, or you could use some approximation using the tributary area method for calculating this shear. So in this manner you could manually calculate the tau v for shear walls where the software is not giving you results. Okay. All right. So this was query from engineer Manish, and now we move on to next question from engineer Vaibhav Khairnar. He's from Nashik, and he's a postgraduate student. So he has a lot of queries. Let me just copy and paste it over here. Let us try to answer his. Let us try to answer them one by one. So his first question is, what is lower bound and upper bound ETABS model? So when we do the backstay analysis, especially in tall buildings as per IS 16700, when you do the backstay analysis, then the code tells you that you take the two stiffness values, upper bound and lower bound, for those elements which are providing the backstay effect. So that's why we make those two models, lower bound and upper bound. So understand that it is this upper bound lower bound ETAB model require, or upper bound and lower bound analysis requirement is only for a specific analysis which is called as the backstay analysis, details of which you will find it in the IS 16700 provision, and those upper bound and lower bound stiffness modifier values are also given. So from there you can do this. For the actual changes, you can refer to the codal provisions where it tells you that which stiffnesses need to be modified and how. In our course on tall buildings that we have done, we have dealt with these topics in a lot of detail. So you might be interested in having a look at that course as well. Second question is beam bracket should be allowed or not? Means cantilever beam from main beam without backspan. So he's saying, if this is my column, let's say, and can I have a cantilever beam bracket without backspan? There is no beam or there is no backspan. Can I have just a bracket? Answer is yes, you can of course have it. Preferable would have been having a backspan, but in many of the situations we do this way where we just have a bracket uh, coming out from the column, and it's perfectly all right. You need to be slightly more careful with the sizing of this cantilever, but otherwise it is done. If you could have a backspan, it would be preferable, but if not, still we can live with it. There are enough uh, places where we do provide such brackets without backspan. Mr. Weber is asking beam bracket from beam, not column. Okay. So he's asking beam from beam. So he is asking this. Let me show you a plan view. These are my two columns, and this is my beam in plan. He is asking this kind of a thing where I take a bracket from the beam, and this does not have a backspan. Again, we do such things. It is preferable to have a bracket. It is preferable to have a backspan. But if there is no backspan, still we can do such things where we can take a bracket from the beam also. just need to be careful about the torsion design for this beam, because the bracket that you will have, it will introduce equilibrium torsion in the primary beam. So you have to be careful about the torsion design. But yes, it is done, it can be managed. It is not preferable, but if the condition is such, you may have to do these types of configuration also. Then his next question is how to design coupling beam. So coupling beam design, you can refer to IS 13920. Okay. Details of coupling beam design are given over there. Mainly how to provide diagonal reinforcement, when to provide diagonal reinforcement. Those provisions are given over there. So you could refer to the coupling beam design. Additionally, you could refer to IS 16700 provisions. The design is nothing different, just that you have to introduce diagonal reinforcement for certain L over D ratios. So you could refer. Then in our tall buildings course, we have dealt with the coupling beam design also in quite a lot of detail. So yeah, so coupling beam, how to the next question is how to design NIB. NIB. I'm not sure what NIB means. How to design NIB in ETABS. The L column, T column, which we generally give to resist torsional irregularities in high-rise buildings. Actually, in ETABS or RCDC, it shows very high percentage of steel. Not clear the question. This query, Mr. Weber, is not clear. If you could provide more details. For reducing torsional irregularities in ETAP, some people give moment releases to primary beams, which with connecting columns. Is it allowed? No. So this is all jugaad work. I mean, giving uh, arbitrary moment releases to beams and then not fulfilling it by sufficient detailing practices. It is all jugaad work. So it's not about being allowed or not allowed. It's about whether you will be able to do the proper detailing on site for it or not, and whether what you are going to do on site, does it justify your design assumptions. That is the question that you need to ask. So just doing changes or just doing arbitrary things in software to get favorable results, it's not the correct way, I would say. So many people do this stuff where they will, if let's say this is my wall in plan, shear walls in plan. So in tall buildings or in these types of configurations, residential configurations especially, they will have walls arranged in one direction mainly. Okay. So what they do is that in this direction they will have a wall frame. In the other direction they will release the beams. I don't know why. I mean, so this type of jugaad work they do because their logic is that this wall otherwise has to be designed for greater reinforcement percentage. But I think this type of arbitrary assumptions are not justified. Whatever you are doing in the model, it should also be in sync with what you are going to do in your actual detailing and what will be executed on site. So this type of jugaad I am not in favor of, so to say. So it's not about being allowed or not. It's, as I told you, it's about whether you could do it on site or not, and whether it justifies your philosophy in execution or not. Coming back to this question, how to design nibs. He is saying how to design nibs. The L column, T column, which we generally give nibs. So you mean to say you want to provide this type of a column? So instead of rectangular shape, these are the shapes you want. Is that what your question is? Okay, in the meantime, he's responding. Let me just. Yes, okay. So he wants this type of thing. So for this, you could use section designer option in etabs. For these shapes and for any random shape, you could use the section designer option. And in section designer option, you have the liberty to model whatever you want. You could come up with any shape. You could then define the reinforcement in it also. You could define the reinforcement of your choice, define the reinforcement layout however you want, and then that reinforcement layout for that particular column size, you can assign it in your model, and the software will give you the results for this specific shape. STAD is not able to do these things because STAD takes it to RCDC, but in etabs you can do it using the section designer. Okay, so yes, I'm not calling it as nibs. This is regular L-shaped, T-shaped columns. What we call it as nibs is this. So basically, nib will be, let's say, if I had a C-shaped wall, okay, in plan, this was a core wall, and I were to take these types of elements. These are called as my nibs. Okay, so what you are saying, L-shaped, T-shaped columns are not called as nibs. This is called as nib, where I take some portion out from my wall so that I get a frame action in this direction also. So for that, these elements are called as nibs. Yeah. So these are not L-shaped, T-shaped columns. These are protrusions that we are taking from our RCC wall just to have a uh, just to have a favorable framing. It shows very high percentage of steel. Yeah, so if it is showing, it is showing. I mean, if then you need to investigate why it is showing. You can assign separate peer labels to this portion. You can assign separate peer labels to this portion and then see what are the moments and what is the actual force getting transferred. And if it is showing, then you need to investigate in depth. Maybe because of this small dimension, you may get higher reinforcement percentages. So in that, generally people increase this thickness of the nib, or they might increase the protrusion. So you may have to do such things. Okay, yeah. Then next query: if we design slab in ETABS, it shows very high percentage. Why so? Due to lateral force or diaphragm effect? No, but ETABS does not show percentage. ETABS generally shows reinforcement in AST mm square. ETABS generally shows reinforcement in mm square or mm square per meter. It does not show it in percentage terms. So from where are you getting percentage outputs? Now, if you are designing slab in ETABS, first check using the design preferences. Just select the slab, go to design overrides, I guess, and see what is the grade of reinforcement assigned. What happens many times is that you may have defined the, let's say, FE 500 grade reinforcement, but if you don't give this design override before slab design, it will do the slab design for some different reinforcement grade. So please be very careful about this first, and just see, select the slab, go to design preferences or over, I think go to design overrides, and then check the reinforcement grade first thing. In my experience, I have not come across this thing where ETABS shows high percentage. ETABS does proper reinforcement calculation for the moments. Now, because these are FEM based results, you may get some local maximas at points. So over there, you may get some very high reinforcement values that you need to do averaging for. So you need to do averaging of results based on your understanding of the behavior. You will have to do some averaging, so that may be required, but otherwise I don't think, or in my experience I have not come across this thing that ETABS gives very high reinforcement percentage. Of course, you remember that it's an FEM software, so you will get the reinforcement values for each and every point, and as I told you, at local maximas you may have very high reinforcement values, but that needs to be averaged out, so you need some understanding for it. Okay, all right. Then due to lateral force, no, diaphragm forces generally, though they don't affect the reinforcement percentage as such, because the axial forces in the in plane direction are not so high that they may affect your reinforcement percentage. Khan forum is saying due to distortion ETABS may give high reinforcement, so that is his opinion as per his observation. Okay. Then moving on to next query, can I use beam AST from ETABS directly for site execution as it shows very low ST? See, these types of statements, very low steel, very high steel, these are not statements to be made by an engineer. You need to first understand what ETABS is doing, how it is doing, why you are getting certain reinforcement values, what is the basis for the calculation. Unless you don't understand it, making these type of statements does not uh, what should I say, is not good for an engineer. You should never make these types of statements, very high, very low. Okay, first try and see what is happening in the software, how it is giving you, what is the basis for the calculation, what are the formulae being used. First, go through the ETABS documentation, only then make these types of statements. Okay, not expected from engineer. These are not engineering statements. So again, in my experience, ETABS may have some bugs for beam design, but generally the beam AST is agreeable as per the manual calculations. So if you want to use it directly for your construction drawings, first be confident and be aware of what ETABS is doing or what STAAD is doing or any other software is doing. Once you develop that confidence, then start using it for your actual, let's say, actual construction drawings. His next query is, what are the thumb rules to identify SBC by just seeing it without any geotechnical report? For small projects, owner refuses to carry out SBC or any geotechnical testing. So in such cases, you can provide, you can do some open excavation on site. Do some open excavation on site and try to see what is the strata of soil that you are getting. If you are getting black cotton soil, then in the black cotton soil, uh, you need to remove at least 1.5 to 2 meters of black cotton soil. After that, even after that, if the black cotton soil persists, then around 15 to 17 tons per square meter is a good approximation of bearing capacity. If you start getting, let's say, yellow or muram type of soil, uh, then around 18 to 19, 20 tons per square meter is a good approximation. If you start getting hard strata, okay, which is getting difficult to even break by your the what do you say, if it gets difficult to even break by the arm of your excavation equipments like JCB trucks or these types of options, these types of equipments, then around 25, 26 tons per square meter is the approximate SBC you can get. And if you get very hard strata, rock strata, which is not even which you are not even able to break by these earth moving equipments or backhoes like JCB or other companies, then around 35-40 tons may be taken as the SBC. So these are some of the approximate values that you could take. His next question is how to calculate expansion of building. So for expansion, you need to apply mostly the temperature loads. For temperature load calculations, you can refer to IS 875 Part 5, how to apply temperature loads, load combinations, etc. If we are providing expansion joint, which material should be filled in it? I don't exactly remember the material specification, but it has to be some non-shrink. I think typically some silicon-based compounds are filled or some bituminous compounds are filled in it. Although I don't remember the exact specification. Also remember that if you are going to provide expansion joint, also check it for seismic gaps. That means it should be sufficient as per the seismic gap requirement. So seismic gap is typically calculated as R times delta 1 plus R times delta 2. Okay, where this R1 and R2 will be the response reduction factors of the two adjacent structures, and delta 1, delta 2 are the lateral deflections at that level for earthquake effects. So your seismic gap should also be more than this requirement. Okay. All right. Then his next query is for basement slab, which type of basement should be provided? What does this mean? For basement slab, which type of basement should be provided? Normal footings and beams and slabs for basement, mat footings without beams and slabs. No, so it depends on your design. There cannot be one answer for this. It depends on the bearing capacity. It depends on the pressure that you are getting on the basement slab. It depends on the presence of water table. Then it depends on the column to column span. So depending on all these aspects, you may have to decide whether you want to provide uh, just a thick basement slab. So thick basement slab is like a flat plate or flat slab without drops, or you may want to provide basement slab with beams. So it will be like a slab beam column system. So all these things depend on the structural configuration that you are having, the loads that you have to take, the presence of water table, etc., etc. So no one line answer is, or yes no type of answer is not possible for this question. Okay, good. So these were his questions. Very comprehensive list of questions that he had put. Mr. Weber is adding to his earlier query about the beam reinforcement. He is saying actually it takes T action and continuity of beam, but in case of RCDC it does not take T action. What is T action? Oh, you mean the T beam L beam effect? No, so if you define your beam cross section in ETABS as rectangular section, it will not consider any T action effect. No, it won't. Okay, it will not consider any T action or L action effect unless you have given a T section or L section in your ETABS section definition. It won't take it. And understand that RCDC is only a post processor. RCDC is not doing any analysis. RCDC is just a calculator where where you put your analysis results. It gives you the AST depending on the uh, formulae. So it's not an analysis tool. Okay. Yeah. Done. So these were his queries. Now we move on to next question. Next question is from engineer Lakshmi Rajesh. She is from Bengaluru and she is an independent consultant. She is asking about pile foundation design in SAFE. Pile foundation design in SAFE. First, you need to know the stiffness. So see, first you need to know the stiffness of these piles. This you can typically get from the geotechnical report, or then you may have to look at the load settlement curve of your pile, and from there you could approximately calculate the pile stiffness, spring stiffness. uh, Once you know the spring stiffness, then what you can do, you make those points in safe, assign them as pile properties, sorry, assign them the pile spring properties, assign them some size. For punching calculations we will need them, and let's say this is your column point which is going to be loaded. Then you make this type of a slab in safe. So section wise it will be like this is my column, and this is my b pile cap, let's say, and these are the 2 points where I have assigned supports, and supports I have assigned spring supports, spring stiffness. Okay, once you do that, then you do the analysis. You will get the reactions on the pile. You have to check and ensure that these reactions on the pile that you are getting are less than pile capacities in compression, in tension, and in lateral. So you need to ensure that. So once you do it, once that is ensured, then you could proceed ahead with your pile cap design. So this is my pile cap. So you could proceed with the pile cap design, and you will get the moment shears in this pile cap. You will get the punching ratio below the column. You will get the punching ratio in pile. So from there, then you can finalize your pile cap design. Now for the pile in safe, you can only check the pile reactions and compare it with the pile capacity. That's the only thing you can do in safe. Now if you want to find out the reinforcement of pile, then you may have to go to, let's say, this IS 2911 part 1 section 2, where it tells you how to calculate the reinforcement for pile. Sometimes we may have to use the concepts of depth of fixity. Okay, so depth of fixity concepts, depending on the lateral load, you may have to calculate the reinforcement. So then you need to do all those concepts, use all those concepts, but they have to be done on your own using manual calculations or Excel spreadsheets, because safe will not do it for you. Safe will only, in safe you can only do this thing, where you can just assign spring properties at pile locations, spring stiffness, and sorry, point springs at pile locations, and you will just get the reactions in the pile, and those reactions you will have to ensure are less than the pile capacities. Rest all you will have to do on your own. Safe will not give those outputs for you. Okay, yeah, okay, so this was her question. Then next query is from engineer Sanjay Kumar from Kolkata. He is a working professional. He is asking, could you explain the design of shear key, as it is not covered in the PEB course? I think by shear key, I'm not sure what he means, but I think he means this. So if this is my column in sectional view, and let's say this is resting on a base plate, and then this is my RCC pedestal. If your column has large amounts of lateral thrust, lateral force, sometimes your anchor bolts may not be sufficient enough, and for those situations you may have to provide a projection of the steel column inside the concrete and get it cast inside the concrete. So this is called as the shear key. Yeah, so this item is covered in the ACI 318. I think chapter 17 covers this. So you could refer to ACI 318 chapter 17, where it does give you the calculations for shear key. Shear key is given to the columns inside the pedestal, and if you use Idea Statica software does these calculations for shear key. However, it uses a different older code. It uses a different code. Actually, it uses some ACI 352 or something. which now you need not refer to. You can refer to ACI 318 chapter 17 now for shear key calculations. So those calculations are given in this chapter 17. You could refer over there. Okay. All right. Then the next query is from engineer Allah Bakash. He is a working professional. Allah Baksh is a working professional from Hyderabad. And what he is asking, I have couple of questions. Precaution to be taken while excavation of foundation for of new building with respect to existing adjacent building to avoid failure to failure of existing building. So for this, if you are having very deep excavations, then you may have to provide what is called as sheet piling. So for example, in sectional view, if this is my existing building and you want to come up with a adjacent building over here, now you start excavating. So when you start excavating, you have to be mindful that this will also have footings. Okay, so it depends on the soil strata, first of all. Now, if your strata is quite hard, then you may not have failure of collapse. If it is a uh, strata which may undergo collapse, then generally in the geotech report, they tell you what slope to maintain, how to manage deep excavations. In the geotechnical report, generally they also give you the guidelines for shoring or sheet piling, whereby you can uh, sort of confine the existing foundations and ensure that their soil does not collapse. So you may have to use sheet piling or shoring. Of course, that is true for deeper excavations. If you had hard strata, maybe you will not be very worried about these things. But in stratas where it is prone to collapse, where the soil cohesion is less, over there you may have to come up with these systems. Typically, these systems you may also design it, but the guidance and requirement is generally given by the geotechnical engineers. One thing. Second, after designing the individual isolated or combined foundation, if pressure bulb overlaps, then what should be the solution for this? See, generally pressure bulb overlaps at, so according to the Bossinist's theory, there is this pressure bulb sort of a thing that you get. Okay, and typically these are the pressure bulbs. So see, the general pressures below the column are concentrated in this region, and as you move away, your pressure values reduce. Similarly, the pressure values reduce as you move radially away also, and in the depth also. So if the pressure bulbs are merging into each other, ideally you will have to add up their values. But what I'm trying to tell you over here is that because in this region the pressure value is also less, most of the pressure is concentrated in this region just below the column. In the outer periphery, generally the pressure values are also small. So even if these two values add up, usually you will see that their values will be less than the SBC. Also, as you move deeper, your bearing capacity also increases more and more. So what you are getting, your bearing capacity at this level, you will get usually higher bearing capacities at deeper depths. That's why when you do the bearing capacity checks, you go up to, let's say, even though you are going to put your footing at, let's say, 3 meter below the NGL, you will do the exploration till, let's say, 10 meters. Why we are doing that? Just to understand what is the strata at deeper levels. Why? Because when these pressure bulbs start merging into each other and where there's an increase in the bearing pressure values, you just need to see whether at lower depths Are you getting any areas where the bearing capacity suddenly reduces? If not, then generally it won't be a problem because of two things, as I told you, that pressure bulbs generally may merge on the peripheral regions. Here, anyway, the pressure is lower, bearing pressure is lower in these regions of the footing, number one. And as you go below, your bearing capacity of the soil strata increases. So even if there was a merging and addition of the bearing pressures, pressure bulb merging into each other, still usually it will be lesser than the increased SBC that you get at deeper strata. So generally, this pressure bulb overlapping, therefore, is not paid a lot of attention. But yeah, it should be thought about. But generally, practicing engineers don't give a lot of attention to this aspect. Probably because of these two reasons. Yeah, good. So these were the queries that were there on the Google form, and yes, Mr. Weber is saying that this shear key may also be called as shear lugs. Yes, you're right. It may also be called as a shear lug. So these were the queries in the Google form. Let me just see in the email if there were any queries that were asked. In the email, no query in the email. So let me take the queries from the live comments. So Khan Forum is saying, can you please give some reference books for design of C and Z purlin? I don't have any ready recommendation for book, uh, but I think any book that covers cold form design should help you with the design of C and Z purlin also. Additionally, I was trying to search. There are these standard tables that I had about the purlin, where for a general span, so many of the suppliers of purlins, they give these standard tables, capacity tables for purlins, depending on their uh, section size and span and loading. So I had that table, but somehow I'm not able to get it right now. So either you could refer to those types of tables, or then you could, I'm not getting it, or then you could refer to some textbook which covers cold form design. So any book that covers cold form design should cover the CNZ Perlin also. Okay. All right. So that was the query. And I think we have taken all the queries from the YouTube live comments as well. So if there is any further question, we will take it up. Mr. Magaj is asking what type of connection we need to provide if rafter is supported by RCC columns. Rafter getting supported on RCC columns, you could continue, I mean, you could still provide the same type of connections that you would have otherwise done. That is, let's say this is my RCC column in section, in elevation, and here is my rafter. Okay, so you could still provide a moment connection over here. So this base plate, you could have it as, so in this case you may come up with a double bolted system, double plate system, where this plate, green plate, is already welded to the column, let's say. Okay, and you have these anchor bolts, and then you bring your beam. This is my beam plate, and then this is my beam with stiffeners and with matching holes for these anchors, and then you bring the system over here, do the on-site welding, and then do the bolting also. If you want to avoid on-site welding, maybe just the bolting over here. This can be one of the options. If you wanted to have a shear connection, it will be simple. You could just have this plate pre-welded to the column face, and then you could bring your beam, have cleats over here, and then those cleats could be welded on site. If you wanted bolting on site, you will either need anchor fasteners, or you could have anchor bolts pre cast in your concrete, and then you could come up with the connection. So whatever strategy you want to come up with for the connection, you could do that. Can we provide connection at top of the column? Yes, you could. If you wanted it at the top, then let's say this is my column. I'm showing you the sectional view, and then you could have a base plate type of a thing. If required, maybe anchor bolts also, and then whatever is your rafter. Sorry, this is my rafter, and then you could come up with this connection, either welded or cleat, whatever. So you could do the such thing also. All right. Engineer's advice is asking, is it necessary to release the end moment of secondary beam in RCC building analysis? Because you are not usually able to have a moment connection at beam to beam junction, it is suggested and preferred to release the end moment where your secondary beam merges into primary beam. So the reason is because you will not be able to execute it on site, this type of a connection. Okay. Yeah. Mr. Chetan Mane is saying, I have raised my question in our group. Could you please take that? Okay. So he has raised this question. He has put the screenshot. 7-meter span member is resting on a 3-meter wide trailer bed. It is support provided during transportation. Lashing chains are tied to lock the member with trailer bed. How we should model this instead? What should be the design approach? Do we need to consider beam as full length or cantilever member protruding outside the trailer bed? Okay, I think what he's saying is that this is the width of his trailer truck, and this beam to be transported is 7 meters, and it is held in place through these chains. So what type of analysis you want? This, I mean, it's not loaded, right? So what do you think will happen to this beam? What do you think will happen to this beam? It's just kept on the trailer. What are your apprehensions regarding it? What do you think will happen? It's loaded. Loaded with what? This will have weight. Containers. Oh, okay. So on top of this, you are having container, is it? So I think what I have understood, there will be containers on top of this. Is that what you're saying? Yeah. So for this, I think, see, in this portion anyway is getting rested on the container itself. So over here, you just need to check the shear force transfer, and you need to see whether this web of your plate girder or whatever this member is it sufficient to take the shear forces transferred from this container. That you need to check. I'm assuming that this container is distributing or transferring the force uniformly to this member. Okay, so first thing you need to check that requirement for stiffeners. So you need to check the shear strength of this web. If it is less, then you need to provide stiffeners, transfer stiffeners. One. Second, for this span, you need to check the moment, cantilevering moment, and for that cantilevering moment, this section should be sufficient. You also need to check the deflection for this cantilever, see if that deflection is okay for this container. Does it affect the container in any way? Check that, and then check the shear over here also. These chains are only to take care of any uplift or any unwanted uplift that may come. So I don't think these chains are such a big problem. So you check these two regions. This region for shear stresses, shears, just see if this web is sufficient to take the shear transfer. You could refer to, I think, chapter H of AISC 360 for stiffener calculations. And this protruding portion is a cantilever, so you check for cantilevering moments, you check for shear, and you check for deflections. So I think these types of checks you may have to perform. Okay. Right. And I don't see, I mean, you could do these calculations manually also. So you may not require to go to software. You may do it on the, uh, you may do it on the using manual calculations itself. Yeah. Okay. Good. Regarding this purlin design, I got this table from engineer Adil Khan, and he shared one table which we had shared in one of our groups, but I had forgotten about it. Not forgotten, I was unable to find it out. So these manufacturers, they do give this kind of a standard table for purlins. Okay, and depending on the span and the wind load intensity, they do give you the suggested section to be used for purlins, assuming the purlin spacing to be this, and assuming the grade of material to be this, and this is the span of the purlin. So they give you suggestions regarding the section size. So these types of standard tables you could refer to. This is in response to the purlin question asked, or then you could do some calculations uh, for purlin design. Yeah. Mr. Chetan is continuing. What should be the approach in STAT? No approach, just do some manual calculations. There's no approach required. If you want to do it in STAT, then you make this type of a beam, and this portion 3 meter is fully supported. This is fully supported. Okay, so here you may add nodes, and or you may give some member supports if such type of support system exists. I think no. So you can make closely spaced nodes and give support over here, keep these cantilevers, and then apply the UDL from the container and just do the analysis design. There will be some lateral forces due to acceleration and gravity loads. Yeah, but These containers are in parallel. I am assuming that these containers, or in plan view, you will have this 7-meter beam, and then there will be a 7-meter beam, and you will have a series of such beams, isn't it? Along the trailer width. So in for the in plan direction, if the container starts moving along the trailer length, then you could have these types of bracings to stabilize your beam system. And for vertical acceleration, you could just multiply that vertical acceleration to this container load. So whatever is the container UDL, you could just multiply it by some factor, maybe increase it by 5%, 10%, whatever, to get the acceleration in the gravity direction. For lateral forces, as I told you, uh, I am assuming that these multiple parallel beams that you will have, you will provide sufficient bracing systems. So I don't think any acceleration in this direction along the length of the trailer is going to be such a big problem. Okay. And any acceleration in this direction also, I think you can resolve it in two directions. One will be this direction, and one will be the one will be this direction. So this direction anyway is getting transferred through bracing system through this parallel beam network that you have. And this direction of force, as I understand, it will create tensions in the beam where you are not very worried about. So I think these types of analysis you can try it out. So these are my suggestions uh, on your query. Okay. All right. So I think that's all for this session then. We stop over here. Thank you very much. And next week we will meet again. So during the week, if you want to ask questions, the same Google form you can use. You can use the same Google form. Once every week, we conduct this live session, but the Google form for putting your queries remains the same. So this is the link for that Google form. And if you want to connect with us on WhatsApp, you can click on this link, which I am putting in the live comments. So this is the link if you want to connect with us on WhatsApp. So that's all for this session then. Thank you very much. Bye bye. See you next weekend now.